Hey guys, welcome back to the channel. So today we're gonna talk about something that sounds scary at first, but it's actually way easier than it sounds once you break it down. Measure of central tendency and dispersion. This topic is basically about understanding data and making sense of numbers in psychology and statistics. Before we get into the actual stuff, we need to know the two types of data. So first, we have qualitative data. This is basically non-number data, like opinions, feelings, descriptions, or interview responses. Then we have quantitative data, which is number-based data, like test scores, reaction times, or survey ratings. So one is descriptive and the other involves actual numbers. Now, when psychologists collect a huge amount of data, they obviously can't just stare at hundreds of numbers and magically understand everything. So, what they do first is try to find the center of the data, like the typical or average value. That's where measure of central tendency come in. There are three main measure of central tendency: the mean, the median, and the mode. And honestly, you probably already have used these before without even realizing it. So the mean is basically the average. The median is the middle number when everything is arranged in order. And the mode is just the number that appears the most. So very simple so far. So first, let's start with the mean. To calculate the mean, you just add all the scores together and divide by how many scores there are. This is probably the most common measure researchers use because it includes every single value in the dataset. So in this example, all the scores add up to 47. And since there are 10 scores, we divide 47 by 10 to get 4.7. But here's the problem with the mean. It gets affected really easy by the extreme scores. Like imagine everyone got around 70 marks on a test, but one person got 0. So that one score could drag the whole average down a lot. That's why sometimes the median is more useful. The median is just the middle number after rearranging everything from the smallest to the largest. So it basically splits the data into two equal halves. If there is an odd number of scores, finding the median is very easy because there's one clear middle number. But if there's an even number of scores, you take the two middle numbers and divide them by 2. That gives you the median. The median is really useful when the data has outliers or very weird extreme scores because unlike the mean, those extreme values don't affect it much. So sometimes the median actually gives a better idea of what's typical. Now, the mode is probably the easiest one. It's literally just the value that appears the most times. So if the number of 4 appears more than any other number, then the mode is 4. The cool thing about the mode is just you can even use it with categories. Like if you're asking people their favorite color, the most common answer would be the mode. And just like the median, it's not affected by the extreme scores. So overall, each measure has its own strengths. The mean is great when the data is normal and balanced. The median is better when there are outliers. And the mode is useful for finding the most common response. But here's the thing. Knowing the center of the data only tells us part of the story. We also need to know how spread the data is. And that's where measure of dispersion comes in. Dispersion basically means variability or spread. For example, two classes could both have average scores of 50, but one class might have scores really close together, while another class has scores all over the place. So even though the averages are the same, the data is actually very different. There are three main measures of dispersion: the range, the interquartile range, and the standard deviation. The range is the simplest one. You just subtract the lowest score from the highest score. But the range has a weakness. It only looks at two scores, the highest and the lowest. So one extreme value can completely change it. That's why researchers don't really rely on it by itself. The interquartile range, or the IQR, focuses on the middle 50% of the data. So instead of looking at the extreme ends, it focuses more on the typical spread. To calculate the IQR, we first find the lower quartile and the upper quartile. Then we subtract Q1 from Q3. And because it ignores extreme scores, it's usually more reliable than the range. Now, standard deviation is the really important one. It tells us how far the scores usually are from the mean. So basically, it shows how spread out the data is overall. Calculating the standard deviation looks complicated at first, but the main idea is actually simple. We check how far each score is from the mean, square the differences, find the average of those, and then square root it. So, in this example, the standard deviation is around 4.3. That means the score are usually about 4 points away from the mean on average. Here you can actually visualize the difference between a small and a large standard deviation. With the small standard deviation, the scores stay close or together around the mean, so the data looks more concentrated. But with a large standard deviation, the scores are more spread out, meaning the data is less consistent. So even if the two data sets have the same average, their spread can still be completely different. A small standard deviation means the scores are packed closely together. A large standard deviation means the scores are most spread out. So, in psychology, a high standard deviation usually means people responded very differently from each other. So, this is the end of the video. Thanks for watching, and I'll see you guys in the next video.